Hi, we are Kiefer Johnson and Abby J. Lopresti, and we are doing the Pearl Harbor Tower in Guangzhou, China by SOM. So to start off with the green aspect summary, wind is the main source of energy. However, energy is also produced through geothermal and solar usage. Geothermal energy is also used to help regulate the cooling and heating of the tower, which is done through a use of the water tower and natural ground and earth cooling as well. The interior is further monitored through the use of a double skin facade and automated shading system.
Alright, so for the building description, the building was completed in 2011 and it's office space for a state-owned tobacco company. It is 309 meters tall, which qualifies it as a super tall building with 214,000 square meters. So it has a double-story lobby, Fritted glass ceiling, restaurants, conference center, and office floors. As for materials, it is glass clad with a steel and concrete structure and a triple glazed glass exterior. It has rectangular floor plates and the elevations, which are very important for its wind turbine usage. So on the south elevation is concave, and it's used to guide and direct wind through turbine areas. The north elevation is convex, while the east and west are flat. It has a bullet-shaped roof, and the double skin facade reduces noise penetrations from the outside. Additionally, there is little ductwork in the building, which allows for thinner floor height, which means more stories could be added within this height. And there are curved ceiling panels, which help diffuse light evenly and effectively. Here are just simply some elevations, in addition to a diagram showing how the wind enters the turbines and then exits it and goes around the shape of the roof. And plans, which again deal with mostly the program of the building.
Alright, so for the green building systems themselves, as priorly stated, most of the energy produced is done so through wind means. At the very base and beginning, this is helped and further alonged by the use of the orientation of the building, which is slightly off from the orthogonal grid of Guangzhou. This is done so along with the concave shape of the southern facade to help catch as much wind as possible, and funneling down the vertical face towards the wind turbines. This funneling helps allow or produce 15 times more energy compared to traditional air turbines. A geothermal heatsink is also used throughout the entire building, reducing electrical and water energy consumption. The geothermal heatsink transfers energy stored in the earth or in the groundwater into the building during the winter, helping heat it, as well as out of the building during the summer, and energy that isn't used immediately is stored for later. The HVAC cooling system helps pass water through embedded tubes throughout the building. This helps cool it and heat it, and it also reduces the amount of fan energy and water consumption. The building can also recharge the energy of the earth when the water within the cooling tower falls below natural temperature of the ground. The building utilizes automatic shading systems to help reduce operational costs and maintain the interior atmosphere, and it does so, and the blinds in the shading systems have photovoltaic cells to help take advantage of the sun. The vertical axis of the wind turbines are on the 25th and 30th floors and are used to produce energy along with the solar panels and daylight harvesting systems, and altogether they produce around 1 million kilowatt hours of electricity a year, which is quite a bit. Climate maintenance is done so through raised floor displacement ventilation, as well as the use of the double wall facade and cavity and radiant cooling. The chilled ceiling system, exhaust air heat recovery, and underfloor ventilation are also used to control the interior atmosphere. And the double skin facade allows for a reduce in the amount of internal space dedicated for heating, cooling, and air circulation. This is all very important for China because of their notoriously poor air quality, particularly in Guangzhou, which has a 74 on the Air Quality Index. For comparison, Brooklyn has 50. Full implementation of the abilities will result in the building saving about 30% in energy costs compared to a traditional building. However, it was originally supposed to be 100% energy. They hope to reach 100% energy by doing so through microturbine usage.
All right, so for our LEED evaluation, the building right now is LEED Platinum, which the points are 80 to 110, and through our evaluation we got to 79, which is LEED Gold, but literally just 1 point below Platinum, and so many of the building's successes are through its water efficiency, energy and atmosphere, and indoor environmental quality. Through its various uses of natural resources and wind capture in addition to the HVAC system. And many of the points where we could not give it its full credit was simply because of lack of information, such as we don't know about its building product disclosure and green vehicles. So if any of these are the case, then the points might be much higher and definitely into the LEED Platinum category. However, an issue with this system is, particularly in the case of this building, the first year after it was built, it was unoccupied. So while it was sitting there and catching the wind energy, it wasn't being used for anything, and it wasn't being sold back to the power grid as it had as they claimed that they would be able to do. So it was just sitting there. So how can a building be sustainable that is sitting and taking up space and not doing anything to help the environment or help maintain its sustainability when it is useless, basically? So then in conclusion, so the Pearl River Tower is very impressive for its sustainability. Also, again, due to its size, since it's a super tall building, which are very difficult to gain LEED certification. And again, it's best known for its wind turbines, which catch wind and store the energy for either immediate or later use. And much of its other systems revolve around cooling and light filtration, which takes advantage of alternative resources such as geothermal heat, wind energy, and sun energy. It received the 2012 Excellence in Engineering from the ASHRAE Illinois chapter, the 2010 Green Good Design Award from Chicago Athenaeum, and the 2008 Green Carbon Lowering and Environmental Category Gold Award from the Spark Awards. So as Kiefer had mentioned, while the goal was to be 100% energy efficient, this wasn't able to happen because of zoning restrictions, and it's simply not their fault. This was out of their hands, and they are only able to save 30 to 40% of its energy, and which again is still very impressive. But again, it questions the effectiveness of LEED certifications and what LEED really cares about, because if it's only using 30 to 40% of its energy and this building is certified as LEED Platinum, basically how much better could it be? And if this is LEED Platinum, what is maybe the just standard LEED or LEED Gold? And I guess more of like, what are the different levels in the minimum of respecting this building as in its sustainability successes? Thank you.
Thank you.